everyone, welcome to this video for PROG1198. This topic is about scalar functions, so let's get started. We're going to look at some different ways of creating user-defined functions in our database. So a function is a type of database object that we create once and can call on multiple times. TSQL has several built-in functions that we've been learning to use over the past few terms. We have some functions that we've been using for aggregates, things like sum and count. We have some functions that we've been using for formatting output, like coalesce, concat, and format. And we also have other types of functions that we've been using, things like manipulating dates or retrieving system values. So there's all different kinds of built-in functions. But today we're going to learn how to design our own functions in order to supplement and extend the system-supplied ones. When we want to create a function in the database, all of the different types of functions follow the same sort of syntax. So we start off with a create statement, followed by the word function, and then we give our function a name. As for the function name, the prefix that we use is one of two options, either fn underscore, which is short for function, or sometimes you'll see it written as udf underscore, which is short for user-defined function. So either one of those will be acceptable. I prefer to stick with fn since it more closely aligns with some of the other syntax that we've seen in the course. After we define the name of the function, we have a set of round brackets to provide a space for us to define our input parameters. So you might see some similarities between a function in TSQL and a function in some of the object-oriented languages that we learn, where we specify a list of input parameters, and the input parameters are optional. You may have 0 or more. After that, we specify the data type that is returned by this function. So we use the keyword returns with the S on the end there, followed by the data type. And the data type can be any of our TSQL data types, things like int, varchar, or it could also be the word table. After we finish the function header, we start off with as, and then we can use begin and end to enclose the function statements. If the function only has one line of code, you can leave the begin and end out. They act kind of like brace brackets to enclose the program statements. You'll also notice a return statement at the end of the function. It's easy to mix up returns and return, so I want to draw attention to it. Returns is what is used in the function header to indicate the data type of the function, and the return statement is used to actually pass back the returned value. In a future course, or class, in this course rather, we're going to also study stored procedures. And you'll see that we end up using stored procedures when we go into our clients portion of the class. And you might be wondering, when you get to that point, how a function is different from a stored procedure. They're pretty similar as far as the fact that they're both objects that we create, that provide parameters and return results. But the difference is in how they're used. Most often, a function is intended to generate some kind of result of a calculation. So a function is being used to get something. And most often, stored procedures are intended to take actions or perform operations. So more often, they're doing something. If you want to compare this to an object-oriented language like C#, a stored procedure would be more like a void method. And a function would be a method that has a data type that returns some sort of calculation. Now we're going to take a look at some different types of user-defined functions. In this video, we're going to look at scalar functions. And then I'm going to make an additional video after this one that talks more about table-valued functions. So the difference between these two types of functions are in what they return. So a scalar function returns one single scalar value. So it returns one single thing, one string or one integer, one answer. For a scalar function, we would define it as returning some data type, such as varchar or int, similar to how we would define a variable that just stores one single value. And scalar functions are often called in the select line or the projection of a select statement. If you've used a function like sum or min or max or getDate or any of those built-in functions, you'll notice that those are most often used in the select line. And sometimes we use them in the where line too. But they return just one value, and that's what we're going to be focusing on here in this video. The other type of user-defined functions is a table-valued function, and this is a function, of course, that returns a table. A table consists of tabular data, rows and columns, and it's implied that we then are returning many values. So it's not one single value, it's many values. We're returning a table, and actually we define the data type as table. When we have a table-valued function being called, most often that function is used in the from line. And this is used more similarly to when we would have calling from a table or from a view. So this provides for us a created or generated data set that we can treat like a table. So let's focus in on scalar functions now. Here's an example of a scalar function. The name of it is num_emps_in_dept, which is a lot of abbreviations, but it's meant to indicate that this function calculates the number of employees in a department. So we're working with our company example with department and employee tables, and we're going to call on this function to tell us how many employees are in this department. The input parameter here is called decode. So when we define our input parameter, we define a name for the variable and then its data type, including the size if the size is relevant. So our goal here is to pass as an input parameter some value for a department code, and we want to return the number of employees in that department. How many? So we're going to count them. The returns line says it returns an int, which makes sense for what we're trying to accomplish here. If you're counting how many employees are in a particular department, you're counting how many of something that's an integer. Then we have as, and notice the begin and end to enclose the function's code. So in this function, we're declaring a variable called out, and then we're assigning the value of out to be the result of this select query that selects the count of all employees where their department codes equal our input parameter decode. So the count of employees with that particular department code is going to be assigned to the out variable. And you can see in the next line, we're returning the value of the out variable. Now there are shorter ways that you could write this a little bit more efficiently. You can do it without declaring the variable and just return the result of the select query itself. But just to make it as clear as possible that we're declaring an integer and we're returning an integer, which goes along with our returns data type there. So let's start out by putting this function into our database in TSQL. I'll just pause the video while I type it. So here's our function code. I've already switched to the username company database. I'm going to execute my create statement to create the function in our database. We see commands completed successfully. If we want to verify that, we can go into our company database, and the place where we can find our scalar functions is listed under the programmability folder, and then we can look for functions. And you see there's a few different types of functions here. We're working on scalar functions, and we can see the function code in here. So that's where that object is stored in our database hierarchy. Now that it exists, we want to call on it. So to use the function, we need to call it in the select line in this case. And when we call on it, we want to pass, the department code as the parameter. So we have to provide a value for D code when we call on this function. So I'm going to select, and then we're going to put in the name of the function. Now something might happen here that we don't expect, but we'll just go with it for now. Fn. So there's the name of the function. And then we have to provide a value for D code. Let me just make this a little bit bigger. That is 4 characters. So for example, information systems department code. Now you'll notice I don't have a from line. The data that I'm pulling is coming from the function, not from a table. Nothing in this line is referencing any table in this database because this here is just a hard-coded literal. You might also notice that it's not recognizing my function name. So if I execute this, you think, well, where did my function go? I also want to point out this again. Notice the name of the function includes dbo dot. So we have to put the name of the schema when we're calling a user-defined function. And the default schema is dbo. So we say dbo dot, and then we have the name of the function. Now when we execute it, we get the result. It's still in tabular format, but it's one single scalar result, so it'll always be one row, one column, and there's no column name. Now, I can apply a column name using an alias. We can execute that and get a column name on there, but you'll notice I don't need a from line. Now, in order to make this more dynamic, I can use this function to call on every department code and give us a count. Now, I'm just going to comment this out, and we'll start from the other side. If I say select department name, department code from the department table. So we'll start really simple. We have department names and codes. Now I want to add a third column that tells me the number of employees in that department. I have the department code. It's in my select line. So if I now select this piece, we'll just move it down and move it over so we can actually see what we're doing here. So I'm calling the function, but I don't want to always call information systems every time. I'm going to take the department code column and we'll pass that into there. So this causes 4 rows of output, right? When I select every department name and code. So that means we're going to end up calling the function 4 times, one for every unique department code value. So I can use the function in the select line to get a count of the number of employees in every department. So this allows me to simplify this code, which I might do quite often. Previously, if we wanted to do that, we would have had to code this, and we would have had to perform an inner join to employee, and it would have been a lot more complex. But if counting numbers of employees per department is something that we do multiple times, then it's nice to put it in a function, and we can kind of abstract away the details of going to the employee table and then just call on the function when we want to calculate it. Let's look at the next example. In this example, we're going to replace a value manager with the value supervisor. So let's say, for example, we don't like the term manager anymore and we want it to display as supervisor instead. Now this isn't going to update the table. It's just going to provide a different output. in our display. So let's start by looking at what we've got in our employee table. And we can see how some of the employee titles are manager. And when I list those employees, I want to list it as supervisor instead. Now, let's write a select statement that selects our emp first, emp last, emp title. We can pare this down a little bit. So we want to take the emp title, and if the emp title is manager, we want to show supervisor. And if the emp title is not manager, then we want to just leave it alone and show emp title on its own. So we could do an if statement, or we can do a case statement in the select line, but I think it would be a lot easier and simpler if I could just call on a function. So rather than writing a case statement in my select line, I'm going to call on a function, pass the employee title in, and it will pass something back, either supervisor or the original title. So here's the goal of this function. It's going to take some input that is a varchar, and it says if that input is a manager, then we're going to return the string supervisor. Now, if the input is not a manager, then we would not perform the returning supervisor. We'd go to the next line here, which is returning the same input that you were already given, unchanged. So let's put this code into our TSQL. Just paste that in here like that. So I'll execute this to create the function. And to test it out, before we go ahead and start using it to work on our employees, I'm going to select it on its own. Oops, underscore. And I'm going to pass some input. So we'll say salesperson. Now, if we say salesperson, that should not change. And it didn't. It still says salesperson. And if it says CEO here, we can pass any string, and the same string will be returned to us. The only time anything different will be returned is if the input string says manager. So let's try that out. If I put in the word manager, you can see how it returns supervisor. So this is a way of producing some different output without actually changing the data in the underlying table. So we want to list these people as supervisors, even though in the system they're truly managers. Okay, so let's get our select line from above. Just move that down. And instead of showing the employee title, I'm going to call the function and pass the employee title as the parameter. Need to do some batching here to get rid of that error message. So we're going to see first name, last name, and the results of this function given the employee title. And so for every different employee title that we encounter, the function's going to execute once per employee. Oh, we need an alias here. We'll just call it title. So we can take a look, and those employees who were managers are now listed as supervisors. Everyone else's title is the same as it was before. So calling something like this allows us to hide the details of the implementation. Rather than, muddying up our select line with conditional logic, it's much nicer to just call on a function and hide it away. So here's that example of selecting some of the fields, including calling a function. If you want to make changes to an existing scalar function, use an alter statement and provide a new definition for the function code. So sometimes it's not quite so easy to just drop and remake something if you want to change it. You can choose to alter instead. So let's say if it wasn't actually managers that we wanted to replace, it was supposed to be analysts. I want to make a change here. You can't recreate a function that currently exists. So we would just say this has now become an alter statement. So we can execute the alter statement to overwrite the existing function definition. And then from there, you can see managers are unchanged, and it will be the analysts who become supervisor. Now keep in mind again, nothing's actually changing in the underlying table. If I select the employee title along with it, I'll give it a different name here, we can see that the table data isn't changed. Okay, and last but not least, if we want to remove a function from the database, you can write drop function and you put in the name. And whenever you refer to the name, you must include the schema for user-defined functions. Okay, so that is it for scalar functions. In the next video, we'll take a look at table-valued functions.